Hello and welcome to another one of D's ADD videos. Quick little intro. I made a mistake when I copied this problem down. This in the video is going to show up as a minus sign at the beginning. It should be a plus sign. So for those of you that are pausing the videos like you should be and trying these problems on your own, please make that note. It's going to change back to a minus sign, but midway through the problem, I'm going to be changing it to that plus sign you see there with a red marker. Okay? So again, it's going to switch to a minus sign, but when you do the problem, do it with a plus sign, otherwise it won't work. Okay? And sorry about the double intro, because you're about to hear another intro. All right? Good luck. Hello and welcome to another one of D's ADD videos. Today we're going to look at a few examples of factoring higher order polynomials using the P over Q method. So recap real quick, whenever you're trying to factor out a polynomial that's more than power of x squared, try factoring out a common term first. If that doesn't work, try factoring by grouping. If not, then we got to do the P over Q method where we list all the P's, which are factors of this constant, the term with no variable, and then we list all the Q's, which are factors of the leading coefficient, the term of the highest degree. And then you create a list of P over Q. These are your candidates for your roots, and then you're going to either plug in until you get 0 using the factoring theorem and then use synthetic division, or just keep doing synthetic division with these possible P's over Q's as your roots until you get a 0 remainder. Either way, you keep doing the synthetic division until you get to a quadratic equation, then you factor like you've been factoring for a while. So let's look at these two examples here. First one, we have a polynomial that consists of 4 monomials. So the first thing you should ask yourself is, can I do factoring by grouping? And here, if I group the first two together, sure, there's an x squared common, and I'd be left with a x minus 1. And then on these two, if I factor out a 9, negative 9, I guess, I get a 3, oh, sorry, that won't work, will it? This is what happens when you record videos at early in the morning. Let's try factoring out a negative 3, and that would leave me a 7x minus 15. And since these two expressions don't equal each other, you cannot do grouping. Had they equaled each other, then you don't even need to do P's over Q's, okay? So, since we cannot do grouping, we try P over Q's. So, I'm going to list the P's, I'm going to list the Q's, and then we're going to do our synthetic division. So, P over Q, or P. So, P comes from this constant here, and all the factors are going to be plus or minus 1, plus or minus 3, because 3 times 15 is 45. Let's see what else goes in there. 5 goes in there, right? Plus or minus, because 9 times 5. And then the 9, and then the 15, and then the 45. And then we have the Q's. In this case, Q's come from the leading coefficient. If there's nothing there, what's understood to be there? Always a 1, okay? So we have plus or minus 1. So in this case, our P over Q list, since Q is 1, is going to be the same as P. Okay, it's not always like that. As you can see on this next problem, you see how there's a 2 right there? That would add a few different terms here at the end if we had a coefficient besides 1. So here, hopefully I don't need to rewrite it. Just look up here for that list of numbers. They would go down here. On a test, you should just go ahead and rewrite them. It's no big deal. But I guess it will only take me a second. So these are your candidates for your... No need to be lazy, right? It's early in the morning, but we can still So now what we can do is we can use the factor theorem and plug in our roots until we get to 0. So we would be plugging, oh, I just noticed this should be a plus sign right here. Sorry guys. Shouldn't affect any of the steps up until now, but had I continued, it would have been tragic. So plus 1 squared, and you should see that that's not going to equal 0. So 21 times 1 minus 45. And then you would try a -1, and then a -2, and a +2. In this case, since I'm the one that created the problem, I know that -3 will work. You can verify this on your calculator if you have it handy. This should equal 0 when you plug in. Okay. So now what we do is we write the coefficients down of your polynomial: 1, 1, -21, and -45. And then the root goes on the outside of our synthetic division line. Not too straight line it seems, but that's fine. You're here for the knowledge, right? Not the artistic capabilities. So bring down the 1, multiply, you get a -3. You add these two together, and when you add these two together, you're going to get a -2. And then you multiply these two, you get a +6. When you add these two together, you get a -15. And then here, when you multiply, you get 45, which is 0. Now, a lot of people, what they prefer to do, including myself, is they just prefer to do the synthetic division with the roots until you get a remainder of 0. If you got some scratch paper handy, or you just erase or whatever, this method is a little bit quicker because you don't have to deal with numbers and plugging in and possibility of making a sign error on your calculator. Synthetic division is pretty straightforward and to the point. Okay, so right now what that tells me is one of my factors, if I was asked to factor this polynomial, would be this, and then the other one that's left over would be this one here. And if we were to look at the coefficients, you would get this as the variables, because it was a cubic function, if you remember, and I divided by 1 root, so now I have a quadratic function. So you can factor this one by grouping. In this case, it's probably easier just to do your guesswork, right? Because you can look at that and say the factors of -2 or of -15 times 1 that add up to -2 are going to be a +3 and a -5. So we factor as follows. And then if you were asked for this answer in fully factored form, this would be what you got. Okay. If not, if you were asked for the roots, you would need to set each of those individually equal to 0. You don't worry about the squared because you square root both sides. Square root of 0 is 0, and you would get x equals -3 is one root, and x equals 5 for the other root. So if we had set the whole function equal to 0, searching for the x-intercepts, for instance, these would be the points that they occur at. Don't forget your x-intercepts have a x comma y, so if that was the case, it'd be -3, 0, 5, 0. Or if they were just finding the roots, then that would be your answer. Okay. This video is taking a little bit longer than I thought, so I'm going to do this next example as a separate video for P's over Q's. Okay. So I hope I've clarified any confusion that you might have. Please practice this. It'll be a lifesaver in your higher level math classes. If you're not allowed to use a calculator. So practice, practice, practice. Thank you and have a nice day. Sorry, getting the hiccups, it looks like.